Hello students, let us continue our chapter Complex Numbers and Quadratic Equations. In this, today we will study about the modulus and the conjugate of a complex number. So, what we will study today? We will study about the modulus and the conjugate of a complex number. So, for this, let us see, let z is equals to a plus ib be a complex number. Okay, we know that z is equals to a plus b be a complex number. Then modulus of z, is denoted by, the modulus of z is denoted by like this. Okay, is defined to be a non-negative real number. In that we will denote the what? Modulus, and is defined to be a non-negative real number what? Root under a square plus b square. So here mod z is equals to root under a square plus b square, and the conjugate of z is denoted by, z bar like this. Okay, is the complex number a minus ib, is the complex number a minus ib. So we can say that is this one. This one, z bar is equals to a minus ib. So this is z conjugate. Okay, this is what z conjugate is equals to a minus ib. So z is equals to a plus ib and z conjugate is equals to a minus ib. Okay, now let us see the multiplicative inverse of the non-zero complex number z. How we will write the multiplicative inverse? Multiplicative inverse of non-zero, we will write the multiplicative inverse of the non-zero complex number z. How we will write the multiplicative inverse? Okay, so this is given by z inverse. Okay, z inverse. So we know that how to write the inverse, 1 by a plus ib. Okay, z is equals to a plus ib. So z inverse if you want to write, so z inverse in that way, z to the power minus 1 is equals to 1 by a plus ib, which is equals to what? Just you say a by a square plus b square plus I minus b, okay, minus b by a square plus b square. Okay, now see here what we have to do after writing this. Then how we will write? Now see here, so we can write z inverse is equals to a minus ib by what? A square plus b square, which is equals to z conjugate by mod z whole square. Okay, so we can write z inverse is equals to z conjugate by mod z whole square. Z is conjugate we know, and mod z, at the place of mod z what we will write? Root under a square plus b square. Okay, similarly some other properties are there. Okay, so let us see the properties for any two complex number z1 and z2. Okay, for any two complex number, z1 and z2. Okay, we can write first mod z1 z2 is equals to, separately we can write z1 and z2. If z1 divided by z2, so that we write z1 divided by z2 separately, provided z2 not equals to 0. Okay, like this z1 z2. So this can be written by z1 mod by mod z2 provided z2 not equals to 0. Similarly, z1 z2, z1 plus z2, z1 minus z2. Okay, and in the next class we will see the numericals related to it. Till then, have a good day.